Hello students, welcome to Manohar Chemistry YouTube channel live session. So today we are going to discuss few questions related to solutions chapter, that is concentration terms, molarity, molality, mole fraction and all those things we will discuss in detail. First question number 16. That molarity is expressed as, what is the definition of molarity? So molarity is equal to number of moles upon given liter solution or liter solution. So in this, units of moles is what? Mole, and this one is what? Liter. So answer is moles per liter. So your answer moles per liter in two options is there. You can select any option. Moles per liter. Answer is A I am selecting. Okay, this is about molarity. Next one. Second question, 17th one. Mole fraction of a solute in benzene is 0.2. Mole fraction, then find molality. Molality they are asking. So generally this question, if you go for traditional method, it will take lot of time. So when mole fraction is given, molality they are asking. If you go for traditional method, it will take lot of time. So that you can use this formula. Relation between molality and mole fraction. That is xb upon 1 minus xb into 1000 upon ma. 1000 upon ma. Here xb stands for mole fraction of the solute, ma stands for molecular weight of the solvent. So this is molecular weight of the solvent and this is mole fraction. So what is the mole fraction of solute here? 0.2. So that molality is equal to 0.2 upon 1 minus 0.2 into 1000 upon, what is the molecular weight of this benzene? 78 will come. So take 78. So this value will be 0.2 upon this one is 0.8. 0.8. So into 1000 upon 78. 1000 upon 78 will come. So if you simplify this decimal point, it will get cancelled. So 2 1 ja 2 4 ja 4 1 ja 4, 250. Then after 250 upon 78 will come. 250 upon 78. So this is approximately 3.2 will come answer, 3.2. So option A is our answer, option A. Question number 17, option A. Next, the unit of molality. What is the definition of molality? So molality is nothing but number of moles present in kg solvent, right? Number of moles present in kg solvent. Here number of moles, again units mole, and units of the solvent, the weight of the solvent is kg. So that's why what will come, what is the unit of this one? Moles and kg to the power of minus 1 will come. Moles and kg to the power of minus 1. Units of molality is like this. Next, which of the following concentration factor is affected by change in temperature? So which concentration term will be affected by change in temperature? Generally change in temperature related to volume term. If the volume term is there, in any concentration term, if volume is there, then definitely it will be influenced by the temperature. See this one, molarity. Definition of molarity is what? Number of moles upon volume. So here volume is there. So that this is not our answer. Next to molality. What is the definition of molality? Number of moles upon kg solvent. So in this mole fraction is which one affected by change in temperature they are asking, no? Yes, molarity. Question once again I am reading. Which of the following concentration factors is affected by change in temperature? So here volume is there, so this will affect. So remaining will affect or not, that let me check. So it's molality. So number of moles upon kg. So it will not affect by temperature. Mole fraction also will not affect. Weight fraction also will not affect. So answer is what? Molality. Okay. So next. Question number 20. In case of question number 20, what is the molarity of K plus, potassium plus, in aqueous solution that contains 17.4 ppm parts per million of K2SO4? So then what does it mean by 17.4 ppm? 17.4 ppm. 17.4 ppm means that is parts per million. 17.4 ppm means 17.4 milligrams. 17.4 milligrams, otherwise 17.4 into 10 to the power of minus 3 grams. Present in what? This is present in liter solution. They are asking, they are given already here ppm. 17.4 pp. 17.4 ppm means this much milligrams are there in 1 liter solution, they are telling, right? So now you have weight, then you have to calculate what? Molarity. So molarity formula already we know, that is moles upon moles for what? Liter. So how can you calculate moles? Weight upon gram molecular weight we have to do. What is the weight here? 17.4 into 10 to the power of minus 3. 17.4 into 10 raised to the power of minus 3 is the weight. And what is the gram molecular weight of this one? 174 will come. If you simplify this, how much will come? 10 to the power of minus 4 will come. 10 raised to the power of minus 4. Okay. 10 raised to the power of minus 4 is what? Moles, this one. Not molarity. This is moles. Then what is the formula for molarity? Moles upon volume we have to take, but here volume is not given. They are asking K plus molarity. So this is 10 to the power of minus 4 present in liter solution. 10 to the power of minus 4 present in liter solution. Then they are asking molarity of K plus ion. So you can take like this. If 1 mole of K2SO4 dissociates, 1 mole of K2SO4 dissociates, it will produce 2 K plus and SO4 minus 2, right? 1 mole will dissociate and how many moles of K plus will produce? 2. 1 mole dissociate and 2 moles of ions will produce. But we have how many moles with us? 10 to the power of minus 4 moles are there. 10 to the power of minus 4 moles will produce how much? That is 2 into 10 raised to the power of minus 4. So what will be answer? 2 into 10 to the power of minus 4. Option D will be your answer. I hope this question is clear to you. Question number 20 completed. Which questions are completed? I will cross like this. Then it will be easy to you. Right. Next one. Which of the following concentration units is independent of temperature? This question is similar to question number 19. Okay, which of the following concentration unit is independent of temperature? Which one will not depend on temperature? They are asking. Just now we discussed, no, which concentration term is having volume that will depend on temperature. Am I right? So in this normality, in formula of normality, number of equivalent moles upon volume will come. So means here volume is there. Means it will depend on temperature. A will depend on temperature. So this is not your answer. Next, molarity. What is the formula of molarity? Number of moles upon volume. So means it will depend on temperature. So this is not our answer. Molality. Number of moles upon kg. So in this volume is given? No. Volume is not required. So means it will not depend on temperature. So what will be your answer now? So C will be your answer. Which one is independent of temperature? Which one will not depend on temperature? They are asking. Option is C. I hope the question is clear to you. Next one, we'll go for question number 22. How many gram of dibasic acid, molecular weight 200, should be present in 100 ml of the aqueous solution to give 0.1 normal? Means normality they given to you already. In case of question number 22, normality they given. Normality is how much? That is 0.1 normal. So you just write the formula of normality, then you can understand easily. So I am solving question number 22 here. Question number 22. Okay. So what is the formula for normality? Normality is equal to weight upon gram equivalent weight. Weight upon gram equivalent weight into 1000 upon V in ml. 1000 upon V in ml will come. So this is normality formula. First, the students will face problem how to extract the data in physical chemistry. First, write on. These are basic level questions actually. If you solve these basic level questions, you can go for advanced level questions or mains level questions. These are basic questions whichever I am discussing. To make your concepts very strong, that's why I am taking easy questions to you. Normality is given here, that is 0.1. 0.1. So weight is how much? They are asking weight only, I think so. How many grams? So let it be X. So then what is gram equivalent weight? Gram equivalent weight means gram molecular weight upon n factor will take, right? Again 1000 upon V in ml. 1000 upon V in ml. Volume is how much? They have given 100 ml. So you can take 100 here in place of V. Now you see clearly dibasic acid they are saying. Dibasic acid means n factor is how much? N factor is 2. Dibasic acid. So here n factor will come 2. Dibasic acid means it will release 2 protons. 0.1 is equal to X upon. What is a gram molecular weight? 200. So you take 200 here. 200 upon 2 will come into 100 1 ja 100 10 ja. Okay, here 10 will come upside. So when you take this one, when you simplify this, what will be the answer? So let me take this page again. Yeah, what will be answer now? 0.1 is equal to x into 2 upon 200 into 10. Okay, 2 1 ja, 2 10 ja, 200 ja. Okay, 100 1, 10 1 ja, 10 10 ja. Okay, now x is equal to how much? 0.1 into 10. 0.1 into 10 means how much? 1. So answer is 1 normal. So sorry, answer is 1 gram. So this 23 option D is your answer. This question also completed, so that I will make it cross. Next we will go for question number 23. So in case of question number 23, 5 molar solution of H2SO4 is diluted to 1 liter. Means molarity they are given and they are asking normality for it. So from 5 moles to what? 1 liter. 5 molar solution of H2SO4 is diluted to 1 liter. Means dilution formula we have to use. What is the formula of dilution? M1V1 is equal to what? M2V2. This is formula of dilution. M1V1 is equal to M2V2. What is M1 value here? 5. 5 molar means 5m. What is the volume of this one? 5 molar solution of H2SO4 is diluted from 1 liter. So from 1 liter means initial value is volume is 1. M2 value don't know, that only you have to calculate. X. So to how many liters? 10 liters. Right? So x is equal to how much? 5 1 ja, 5 2 ja. Then x is equal to how much? 1 by 2 will come. Then x is equal to how much? 0.5. This is molarity. Whatever we got here, that is molarity. But we want normality because in question they are asking normality. We have a formula. Normality is equal to n into, means n factor into molarity will come. So what is molarity here? Molarity is 0.5 we got, right? 0.5. Molarity is 0.5. What is n factor of H2SO4? 2 will come because it can release, H2SO4 can release 2 hydrogen, so that's 2 protons. So that's why its n value, n factor will be 2. 0.5 into 2, answer is 1. So answer is B, option B. This question also completed, so let me make it cross. Okay, I hope you are understanding all questions. So let me go for next question. Yeah, next one. What is the total number of moles of H2SO4? Let me clear this because there is no space. So please try to solve the question 24. If anybody is watching in live, please try to solve question number 24. Question number 24. See this. What is the total number of moles of H2SO4 needed to prepare 5 liters of 2 molar solution of H2SO4? Okay. So again here which formula we have to use? Here no need to use dilution formula. You can go for like this. 2 moles present in. 2 molar means what? What is 2 molar? 2 molar. When the molarity will be 2? So when 2 moles present in 1 liter, then the molarity will be 2. Am I right? Yes. So now they are asking 5 liter. What is the total number of moles of H2SO4 needed? So to prepare 2 molar in 1 liter means in 1 liter 2 moles are there. Okay. So to in 5 liter how many moles will present? Then how much? 5 into 2 which is equal to 10. So answer is this one. 24th question, option C will come answer. Okay. Right. Go for question number 25. So this question also completed. Question number 25. Molarity of a given orthophosphoric acid solution is 3m. Molarity they have given and they are asking normality. Orthophosphoric acid. What is the formula of orthophosphoric acid? OH and P double bond O, OH and OH, H3PO4. The formula of orthophosphoric acid is H3PO4. Right. So in this, how many hydrogens it will release this acid? 3 hydrogens it will release. Right. So molarity is equal to what will come? N factor into normality. Sorry, normality is equal to what? Molarity into n factor into molarity will come. Okay. So then n factor is how much here? 3. N factor is 3 and molarity is 3. 9 will come. 3 3 is a 9. So normality is 9. So 23, 25 option A will come. Next. So this question, 26th question. So if you go for any traditional method, means if you are taking volume, density, weight again, so it will be take a lot of time. I will give simple formula to you. Maximum you can use shortcuts or tricks in case of competitive exam. That will be more helpful to you. So in case of question number 26, what is the formula? So to calculate molarity, okay, then weight by weight percentage into 10 into density upon gram molecular weight of the solute. So this is the formula. Weight by weight percentage. How much they given weight by weight percentage? Weight by weight percentage is 98%. 98 here it will come. 10 means 10. Density is how much? 1.84. 1.84 upon. What is the gram molecular weight of H2SO4? H2SO4 gram molecular weight we have to calculate like this. Hydrogen is 2, sulfur is 32 plus this one 4 into 16. How much it will come? 64. 2 plus 32 plus 64 which is equal to what? 98. So here 98 will come. So 98 get cancelled. So 10 into 1.84 which is equal to 18.4 will come. What is answer here? B. Option B is your answer. So like this we have to answer. Go for question number 27. This also completed. Question number 27. A solution is prepared by dissolving 24.5 gram of sodium hydroxide in distilled water to give 1 liter solution. The molarity of NaOH solution is. The direct formula you can use. What is the formula of molarity? So molarity is equal to weight upon gram molecular weight into 1000 upon V in ml. You can use direct formula to calculate this. So molarity is equal to what? Weight upon gram molecular weight into 1000 upon V in ml. 1000 upon V in ml. What is the weight? Weight is how much? 24.5 grams they have given. 24.5. What is the gram molecular weight? 40. 1000 upon 1000 because 1 liter so 1000, otherwise you can take 1 by L directly. So now what will come? So 24.5 upon 40 is nearly 0.6125 will come. So answer is this one. Okay. Next question number 28. Question number 28. What will be the molality of a solution having 18 grams of glucose dissolved in 500 grams of water? Simple formula, direct molality, direct question. This one you can use molality formula. What is the formula of molality? Weight upon gram molecular weight into 1000 upon weight of the solvent. Weight of the solvent should come. So weight is how much they have given? 18 grams. What is the gram molecular weight? 180 into 1000 upon. So what is the weight of the solution? 500 gram. Solvent. Weight of the solvent is 500 gram. 500 1 ja, 500 2 ja. So 2 1 ja, 2 9 ja. So 90. 18 1 ja, 18 5 ja. So 1 by 5 will come, which is equal to 0.2. So answer is this one. I hope this answer is clear to you. Next one. We'll go for question number 29. Sorry. Question number 29. Before going to solve question number 29, let me clear this. Yeah. Question number 29. A 5.2 molal aqueous solution of methyl alcohol CH3OH is supplied. What is the mole fraction of methyl alcohol in the solution they are asking? So 5.2 molal. What does it mean by 5.2 molal? 5.2 molal means molality is 5.2. This 5.2 moles. Otherwise you can read it like this. 5.2 moles. 5.2 moles present in how many kg solvent? 1 kg solvent. So means you take here CH3OH and water. CH3OH as well as water. So how many moles are there for CH3OH? That is 5.2. How many moles are there for water? Don't know. So that weight of the solvent is given 1000 grams upon. What is the molecular weight of water? 18. If you cancel this, then you will get 55.55 you will get. So this is 5.2. Right? Then how to write this one? Mole fraction of which one they are asking? Mole fraction of the methyl alcohol. So 5.2 upon 5.2 plus 55.55. So what is the answer? 5.2 upon 5.2 plus this 55.55 means that is 60.55. 75 will come, 60.75. If you simplify this, 0.08 will get 0.08. So answer is this one, 0.08. Okay. So like this we have to solve. Go for question number 30. Question number 30 will do. Question number 30. Yes. What is the molarity of NaOH solution if 250 ml of it contain 1 milligram of NaOH? So weight of the solute they have given, that is 1 milligram, means weight is equal to 1 into 10 to the power of minus 3 grams we can take. Okay, number of moles is equal to weight upon gram molecule weight. 1 into 10 to the power of minus 3 upon 40 will come. So if you simplify this, how much will come? 2.5 into 10 to the power of minus 5 moles will come. That is 2.5 into 10 to the power of minus 5 upon 0.250. Milliliters of solution will be converted to liters. If you simplify this, 10 to the power of minus 4 mu will get. So answer is C. Like this. Okay. Go for next question. Question number 31. Sorry. Question number 31. The partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in the solution is given by. So when we apply pressure on the solution, solubility of the gas will be increased. This is explained by Henry's law. So very clear statement, direct statement. Question number 32, you see carefully. Question number 32. Four gases like hydrogen, helium, methane and CO2 has Henry's constant values. KH are 169.16, 144.979 and 0.413 and 1.67. The gas which is more soluble in liquids. What is the formula of this one? Henry's law, constant and solubility. Pressure is equal to what? KH into mole fraction of the gas. So if pressure is constant, then KH is equal to what will come? P upon what? Mole fraction of the gas. P is equal to KH is equal to P upon mole fraction of the gas. Means if the KH value is greater, then solubility of the gas will be decreased. Means inversely proportional is there. Relation is inversely proportional relation. So which one is having smaller KH value here? If you observe carefully, hydrogen is 69. Okay, helium is 144 and CH4 is 0.413 and carbon dioxide is 1.67. Which one is having less? That is CH4, I think so. CH4 fourth value, third value, 1 2 3 third value. So methane is answer like this. Okay, which one is having smaller KH value? That one will have greater solubility. It inversely proportional. No? If this is smaller, then this will be greater. The solubility of a gas in a liquid increases with. Then what we have to do? Solubility of the gas should increase with decrease in temperature, because if you are increasing temperature, if temperature increases, kinetic energy of the gas molecule will increase and it will escape from the surface. And by default, gases solubility is exothermic reaction. According to Le Chatelier principle, exothermic reactions are favored by lower temperature, that we know. So here temperature decreases, then solubility will increase. So answer is C. Next one, solubility of a substance is its maximum amount can be dissolved in a specified amount of solvent. It depends on. So it depends on nature of the solute, because like dissolves in like. So nature of the solute it will depend, and nature of the solvent it will depend, temperature and pressure it will depend on all. So if the gas is there, we have to consider pressure also. That's why we have to consider all. Okay. So I hope you like this video. So if you in future I will conduct live classes. If you are interested, you can join. Thank you. Have a nice day. I'm closing live.